So, have you ever wondered how we can make informed decisions based on data? One of the ways we do this is through a process known as hypothesis testing. Intriguing, isn't it? Hypothesis testing, in essence, is a method of statistical inference. It's a tool that allows us to put a claim or a prediction to the test based on the data we have. The process is quite interesting. We begin by comparing two competing hypotheses. The first is the null hypothesis, which is essentially the status quo or the default assumption. The second is the alternative hypothesis, which represents the claim or prediction we want to test. Imagine, for instance, we want to test whether a new drug is effective in reducing blood pressure. The null hypothesis would state that the drug has no effect, while the alternative hypothesis would suggest that the drug does indeed lower blood pressure. To test these hypotheses, we need data. We collect a sample of patients who take the drug, measure their blood pressure before and after the treatment, and then analyze this data. The analysis involves calculating a test statistic. This statistic summarizes the difference between the two groups, giving us an idea of how likely it is to observe such a difference if the null hypothesis is true. Now here's where it gets even more interesting. If the test statistic is very small, it means that the difference is not significant, and we cannot reject the null hypothesis. In other words, we don't have enough evidence to support the claim that the drug is effective. But if the test statistic is very large, it means that the difference is significant, and we can reject the null hypothesis. This means that we have enough evidence to support the claim that the drug lowers blood pressure. But hold on, we must also be careful about interpreting the results. There's always a possibility of making a wrong decision due to random variation or sampling error. That's why we also report a p-value, which is the probability of observing a test statistic as extreme, or even more extreme than the one we obtained, if the null hypothesis is true. The smaller the p-value, the stronger the evidence against the null hypothesis. Hypothesis testing is a powerful tool for making decisions based on data, but it's not without its challenges. For instance, we have to choose an appropriate level of significance, which is the threshold for rejecting or accepting the null hypothesis. We also need to consider the power of the test, which is the probability of correctly rejecting the null hypothesis when it's false. And we must always be aware of potential biases or confounding factors that may affect the validity of our conclusions. In conclusion, hypothesis testing is a fascinating yet complex process that helps us evaluate claims or predictions based on data. It's an essential tool in the world of data analysis, but it must always be used with a careful design, thorough analysis, and mindful interpretation of data.